Okay, the next thing we're looking for here with our soccer ball problem is the time it's going to take for the ball to reach its maximum height. Now, there's something special about that maximum height. When the ball or any projectile reaches the peak of its trajectory, the highest point in its trajectory, its vertical velocity at that instant is 0. In other words, that's the point where it's transitioning from moving upward to coming back downward. So the vertical velocity at that one particular instant is 0. So we can make use of that to figure out how much time it's going to take to get it to that point, and also we can use that to determine how high it's going to be above the ground at that point. So we've got a couple of other pieces of information that we know. We know that vertically the acceleration is negative 9.8, and we also know that vertically the ball was moving upward at 7.5 meters per second just after it left the kicker's foot. Now, let's think about here what we want to find. We want to find the height, which is delta y, and we don't know the time. We do have an equation that relates the velocity, the final velocity, the acceleration, the displacement, and the initial velocity to each other without needing to know the time. That was one of our Unit 2 equations. And so if we go ahead and solve for this, delta y, we can solve for delta y in this equation. That is going to represent for us how much higher the ball is when it reaches the top of its trajectory, how much higher it is from where it was kicked. Now that's not the height above the ground, but all we have to do is add 50 meters to that, since the ball started 50 meters above the ground, to get the total height of the ball from the ground at the peak of its trajectory. So let's go ahead and do that. We'll solve for delta y, and we'll add 50 to it, and that will give us the height above the ground, because that's what was asked for here. So at the peak of its trajectory, its vertical velocity is 0. Vertically, the ball is in free fall, so a is negative 9.8. We're solving for the height above the kicking point, above the launch point, as delta y, with an initial vertical velocity of 7.5. So I'm going to pause the video, do that calculation, and you do the same. Okay, so working this out, delta y works out to be about 2.87 meters. And again, that's how much higher the ball is above the release point. That's how high it's risen since it was kicked until it reaches the highest point in its trajectory. The total height above ground is simply found by taking that 2.87 meters that it is above the kicking point and adding the 50 meters that it already was above the ground. So 52.87 meters is its height above the ground at the highest point in its trajectory. Now, part C is asking us how fast the ball is moving horizontally, the x component of its velocity, just before it lands. And remember, since there are no forces acting on the ball horizontally, that horizontal component of its initial velocity has never changed. So it is still moving at 13 meters per second just before it lands. Now the y component of its initial velocity has been changing throughout the flight of the soccer ball, and that's because of the unbalanced force of gravity. So in the y direction, we're going to be looking for the final velocity, the velocity just before it lands. We've got the vertical acceleration. We've got the initial vertical velocity. And we do have the time. We know the time of flight from the time it was kicked until the time it landed, and that was a value that we had back from part A, and that was 4.1 seconds. So again, looking at our equations, we have this equation which we are applying to the y direction, and we're looking for the velocity in the y direction just before landing, and that's when the ball has been flying through the air for 4.1 seconds. So let's go ahead and calculate this out, and this will give us the y component of its final velocity. Okay, so the y component of that soccer ball's velocity, just before it strikes the ground, it's just about to touch the ground but hasn't quite made contact yet, works out to be negative 32.7. And it does make sense that this answer would come out negative because the ball is moving in the downward direction right before it touches ground. Alright, the final thing we're looking for in this problem is we're looking for the magnitude, in other words the size and direction of the ball's total velocity just before landing. So let's think about what the ball's doing just before it lands. Let's look at our motion map up above. We're looking at this picture of it right here. It's moving rightward with a horizontal velocity component of 13 meters per second, and now we know, and that's this component right here, and now we know the vertical component, this component right here, is negative 32.7. So let's redraw that down here below. So we've got a horizontal velocity component of 13. We'll draw these two velocity components out head to tail. So off the head of this one, here's our 32.7 meter per second velocity. Now I'm dropping off the negative sign because the arrow is showing that the velocity there is downward. And here is the hypotenuse. So that represents the total velocity of the ball just before it makes contact with the ground. And then here's the angle, theta. And so we can now use a little bit of trigonometry to figure out the hypotenuse of this triangle and the angle, and that'll be the magnitude and direction of the soccer ball's total velocity. So to find the hypotenuse, we're going to use the Pythagorean theorem. So we'll square the two legs and add them together, and then take the square root. And then to find the direction, the angle, we're going to take the inverse tan of the opposite side divided by the adjacent side. So I'm going to pause the video and I'll finish off those calculations, and you do so also. Our soccer ball's velocity just before it strikes the ground, total velocity is 35.2 meters per second. Okay, that's a result of it having a velocity of 13 meters per second in the horizontal direction, but also a vertical velocity of 32.7 meters per second downward in the y direction. And it comes in at a very steep angle of about 68.3 degrees. So that's 68.3 degrees below the horizontal. So use these examples to help you with the post-lab problems. And of course, if you have any questions, make sure to email me at ctodd@pointpleasant.k12.nj.us.